Alrighty, today we are reviewing solving equations 1 and 2 step for the first part. Just one step and 2 steps, for this first video. So this is the 6th and the 7th grade version of what we have learned about this topic already. So first we have some quick vocabulary words to review. The first one is a math sentence with an equal sign. That is an equation. That is an equation. The next word, a letter that represents a number, is a variable. A variable. Those first two words are probably familiar to most of us. Then we get into this word that we used last year pretty heavily when we're talking about this, and it is the word for opposite operations. Opposite operations, we're going to use the word inverse. Inverse operations. When you hear me talk about opposite operations, I'm talking about inverse. So that's like addition and subtraction. Those are opposite operations. They undo each other. Multiplication and division, those are opposite. Those are inverse operations that undo each other. To be alone, this isn't just for math. This is also like my brothers drove me crazy growing up. So if I wanted to be alone, I would isolate myself from them. In solving equations, we're going to isolate the variable. We're going to get it all by itself. The multiplicative inverse, I'm sure you guys have heard of this word, but maybe you just don't remember what it is. It's like if I take 1/2 and I flip my numerator and my denominator, so it becomes 2/1. The multiplicative inverse is the reciprocal. Reciprocal, when I flip my numerator and my denominator, the multiplicative inverse. Then we have the number in front of the variable. Last unit, we called it slope most of the time because that was appropriate when we're graphing. But now we were going to use the word coefficient. For this unit, we're going to use a synonym, that word coefficient, to refer to that number in front of the variable. And then last, the number that's by itself, the y-intercept, my b, my coefficient, that's like my m. This number by itself is like my b. The word we're going to use for this now is constant. We use the words y-intercept when we're graphing, but now because we're just seeing the equation, we're going to call it our constant. So these words are all really important. 7 words that you're going to keep hearing us saying and using as we're going through this unit. So please make sure that you've got this written down so that you're comfortable with these words. There's 3 big things that I hope you remember going into this. Before we even start solving problems, there's 3 things that I want to make sure that you remember. So inverse operations, like we already said, inverse means opposite operations. We're using the inverse operations, those opposite operations, to cancel each other out so that we can isolate the variable. The goal of solving equations is to get it so that it's x equals some number. We have to work backwards, so we have to go in the opposite order, use opposite operations to get our variable, our x, whatever letter, all by itself so we know what number it equals. If you had me last year, you heard me call it the river of love. If you had Mrs. Parada, you might have heard her call it as train tracks. But that's when we have our equation. We want to draw a line or something down the middle. We want to make sure that we're doing the same thing. We want to make sure we're doing the same thing to both sides. My equation, something is equal, something is balanced. But if I do something to one side and not the other, my equation becomes unbalanced. It's not equal anymore. So I have to make sure whatever math I do on one side, I have to do that exact same math on the other. And then the last thing that I remember talking about last year was sad meg. Sad meg. Normally we would do GEMDAS. to solve for our expression or our equation that they give us. But now, like we talked about up here, we have to work backwards. We have to do the opposite of what we would normally do to solve these problems. So instead of it being GEMDAS, now to go through and solve for x, we have to do SAD-MEG. So it's the reverse order of operations, or the backwards order of operations. SAD-MEG. Go ahead and pause it if you need to, otherwise I'm going to keep moving on. And we're going to get into some examples of one-step equations. We only have to do one step. We're just doing the opposite of what we see, that addition, subtraction, multiplication, or division. Don't forget you can use your calculator. Some of these questions are going to get a little tricky with the division, with negatives, and all those types of things. No shame in the calculator game, okay? So we get our equation. Right here we see x minus 3 is equal to 4. I want to start off drawing my river of love or my train tracks. Whatever visual thing I want to help me remember that I have to do the same thing to both sides. Whatever I need to do to help me remember, I got to do the same thing to both sides. Oops. Now I need to look at my problem and see what operation's going on there. Here, I see I've got subtraction. So the opposite, the inverse of subtraction would be addition. I'm trying to isolate that x. I'm trying to get it all by itself. So to get rid of that minus 3, I need to add 3 to both sides. When I'm adding this 3, I'm making what we like to call a zero pair. My equation starts off with 3 minuses, but I'm trying to isolate that x. I want to get it all by itself. So to get rid of 3 minuses, if I make 3 pluses, we know a plus and a minus, a positive and a negative, cancel out. They eliminate each other. They make zero pairs. So when I'm subtracting 3 and adding 3, they eliminate. They make a zero pair. And I bring down this x, because I haven't done anything with that yet. And then over here, because I added 3 to the side, I also have to do it here. I see that 4 plus 3 gives me 7. There's no division or multiplication. This is just one step. So we're good there. Our answer is x is equal to 7. We always, always, always want to make sure that we go back and check our work. The way that we check our work is to take whatever we get for our answer, and we need to substitute it back into the original equation. So let's see what that would look like. I plug in my 7 for my x, and then I keep the rest of my equation. Minus 3 equals 4. 7 minus 3 gives me 4. Does 4 equal 4? It sure does. So that lets us know that we got the right answer. I'm not always going to have time to go through and show the work to check it, but I will tell you, lots of my students who do this catch their mistakes. And if they got it wrong the first time, they know to go back and to check to see that to fix what they didn't get. So please, 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 on your formative, on your summative, it is expected that you check your work. Solve all the problems first, then go back and check if you've got time at the end. All right, my next problem. I have x over 2 is equal to 4. I want to start off drawing my river of love. Remember, all that does really is remind me that I have to do the same thing to both sides of my equation. Just a reminder. And I see here that fraction bar. What operation is that fraction bar? Yeah, that's division. But in math, we're getting to upper levels of math and we don't see that symbol really anymore. We're going to start seeing division as fraction bars from now on. So please recognize that that's not a fraction, that means division. Same symbol means division here. So now that I'm going through and solving, I know that that's division. I have to do the inverse. I have to do the opposite operation. So what's the opposite of division? Multiplication. I need to multiply both sides times 2. You see here that I'm using parentheses for the multiplication sign, and that's because if I use the x for multiplication sign, that kind of gets confusing with the x that's in the problem. So when we're solving equations, when we get into solving inequalities, use parentheses to show multiplying times 2. I know multiplication and division are inverse operations, so they eliminate each other. So all I'm left with here is x. So I want to make sure I bring that down. I haven't done anything to it. And then on the right side, 4 times 2 is 8. There's no other math, there's no other operations there, so that's our answer. Again, if I just want to go through, I'm going to check it real fast. If I plug it into my equation, substitute 8 in for x, I see 8 over 2 should give me 4. 8 divided by 2 is 4. 4 equals 4, so I am good. If you need to pause that, rewatch it, go ahead and go back and do that. Otherwise, there are 2 problems here that they're each a little tricky for different reasons. Go ahead, pause the video, try these 2 problems on your own. Check them, make sure that you got the right answer, because I know especially one of these problems, I'm going to show you guys, someone got, or quite a few people got it wrong in class, and we're going to talk about why. So pause the video, try these 2 on your own. Alrighty, let's draw our river of love. Going through doing inverse order of operations. Yours should be done already. We should just be seeing if we got it or not. I see my r's over here. This problem's kind of tricky because we talked in the past about how the term and the symbol in front of it go together. That positive goes with the r. So we really don't see if I should be adding or subtracting that 4 just from this plus. This plus does not tell me if I'm supposed to add or subtract that 4. But like we talked about earlier, this is a positive 4. And how do I get rid of a positive 4? I do the inverse, I do the opposite. I would need to subtract 4. So I should be subtracting 4 from both sides. Again, not because this is a plus sign, but because that number 4 is positive. Negative 3 minus 4 gives me a negative 7. Positive 4 minus 4 eliminate, they make a 0 pair, and I want to bring down my r. So I should get that negative 7 is equal to r on that one. On this one, I draw my river of love. This is the one that people were recognizing when they checked their work that it wasn't right. When my numbers are side by side, that means it's multiplication. The opposite is division. So I'm going to divide both sides by 8. Multiply and divide by 8 makes a 0 pair. So I should get y equals, a lot of people want to put this in their calculator, and they get 0.5. That's not the wrong answer, but that wouldn't be an answer choice if this was a if this was a multiple choice test. I would see something else. I would see something different. What do you think I would see here instead of 0.5? If I simplify my fraction, divide my numerator and my denominator by 4, I see that my fraction simplifies to 1/2. And that is what you would see for your answer choice. You would see 1/2. In class, I had a lot of students do this. all the work is right. They knew that they needed to divide both sides by 8, but we just got excited. We saw 4 and 8. We know 4 goes into 8 2 times, but they divided in the wrong order. But I was so happy that they did that check on the bottom on their own. They did this on their own. I didn't have to tell them to do that because I said earlier, it's expected that you check your answers to make sure that you're right. They did it on their own and they went back and recognized. I didn't have to tell them they were wrong. They figured it out for themselves. I was very proud of this student. Very proud of that student. If you do get a decimal answer, a good test-taking strategy, divide out the fractions and see which one matches up if you're not comfortable simplifying. Good test-taking strategy. Hopefully you got those two. If you have questions, let me know. Otherwise, I'm going to keep on keeping on into the 7th grade version of this. 2-step equations. 2-step equations. Like we've said, we have to do the order of operations in reverse. So instead of GEMDAS, we're doing sad Meg. Sad Meg. Poor Meg, she's so sad. We have to do the inverse order of operations. So I'm going to draw my river of love. To remind myself I need to do the same thing on both sides. I've got to do the same thing on both sides. And then I'm going to start working. Like we talked about, we have to do the subtraction and addition first. The dividing and the multiplying, the part with my variable, that's the second step. So what a lot of students like to do, Mrs. Curtis taught me this trick, she likes to take that coefficient in the variable and put a box around it to remember that we're protecting that, we're saving that for the end. I need to protect that. I need to save that for the end. What I need to do first is the subtraction and addition part. I need to do my subtraction and addition inverse operations first. So here I see I'm subtracting 3 in the problem. The inverse of subtracting 3 would be to add 3. I'm undoing the subtracting of the 3, so I want to make sure I line those two things up. I'm not adding 3 to the coefficient, I'm adding 3 to this constant at the end. That makes a 0 pair, so I can bring down that 3x. 15 plus 3 gives me 18. So that was my first real step, adding or subtracting for the sad part. Now for the dividing and multiplying. Again, I'm still doing the inverse, I'm still doing the opposite. Remember, this is multiplication when they're side by side. The opposite of multiplication is division. We want to use that fraction bar, just in case our answer turns up to be a fraction. What's 18 divided by 3? 6. Multiplying and dividing by 3 cancels each other's out, eliminates each other. I bring down that x, and I see that my answer is 6 is equal to x. If I check my work real quick, substitute 6 in there. 3 times 6 minus 3. 3 times 6 gives me 18. 18 minus 3 gives me 15. So I am good to go. I am good to go. Okay. Let's do another one. This one's got some negatives. This one's got some subtractions, but that's all right. We're going to be just fine because we've got sad Meg. Poor girl. Poor girl, sad Meg. We're going to draw a river of love. We're going to protect our coefficient and our variable. We want to get rid of that constant first. We want to get rid of that constant first by doing our subtraction and addition. Sad Meg. So if I see I'm subtracting 6, what's the opposite? What's the inverse? Adding 6 to both sides. Again, I'm adding 6 to the minus 6. I'm not adding 6 to 4. Those won't cancel each other out. I need to make sure that they're stacked on top and bottom so I know that those go together. Bring down that 4x that we're protecting. Negative 2 plus 6. If you don't know that off the top of your head, it should be 4. No shame in the calculator game. You get it. Use it. I purposely built it in on your Desmo slides for a reason. I did my adding and subtracting. Now I'm going to do my division and multiplication. Side by side means to multiply. So the inverse, the opposite, would be dividing by 4. 4 divided by 4 gives me 1. And that's why this works out. I bring down that x, but really, there's this invisible 1. Because 4 over 4 simplifies to 1, like we just saw over there. There's an invisible 1 right there. But us being math people, we're not going to write it. We're just going to write 1 is equal to x like that. But do know that multiplication and division, I say they make a 0 pair, both multiplication and division, they really make a 1. And we don't write those 1s. We're lazy. We work smarter, not harder. So for that one, we get that 1 is equal to x. All right, the last part of this video, I want you to try these last two on your own. Before you do this green one though, I have a hint for you. To get rid of a fraction, you need to multiply by the reciprocal. That was one of our vocab words from earlier. Remember, the reciprocal is when you flip your numerator and your denominator. Go ahead, pause the video, give those two problems a shot. All right, people, we're doing Sad Meg. My first problem, my river of love. I'm gonna do it on both of them because I'm here. Inverse operations. I have to protect my coefficient and my variable. I'm doing subtraction and addition first. On the left problem, the opposite of adding is subtracting. So I subtract 3 from both sides, bring down my 2x. 23 minus 3 is 20. Now I do my division and multiplication, divide both sides by 2, and I get that x equals 10. This one, again, people get nervous because of the fraction. Well, let's do the first step, not even worried about it. I see minus 1. The inverse is to add 1 to both sides. I bring down my 1/4 x. 2 plus 1 is 3. Now, I know to get rid of that fraction, I need to multiply by the reciprocal. So my numerator and my denominator need to flip. The 1 was on top, now it's going on bottom. The 4 was on bottom, now it's going on top. And I've got to do that same thing to the other side. Remember, if I multiply and divide by the same number, it makes a 1. It makes a 1. So there's really this imaginary 1 here, but I'm just going to write x. I'm just going to write x instead of 1x. If I multiply these together as fractions, 3 times 4 is 12, 1 times 1 is 1, and I rewrite 12 over 1 as simply 12. If you have any questions on this, if you need more of an explanation, please, please, please let us know. Please let us know. And we'll get back to part 2 here in the next link, where we're going over algebra tiles and word problems.